packet, page 1, here we go. Some of this should look very familiar to you, like question number 1. Convert 100 degrees to radians. What's our strategy? Oh, someone say it. Someone help. What's our strategy? How do we change 100 degrees into radians? There you go. Very good. Pi over 180 equals something over 100. Is that okay with everybody? Thank you, Patty.
2 words. Bender, bender. There was one on the hill.
Oh, yeah, but you, not you.
Nope.
You weren't
I don't
involved.
even drive, so.
Okay. Well, I'm glad it's not you.
Another news.
I hope it's no one I know.
Yes.
You sit here, bro.
I guess.
But as long as it's just a fender bender, that's okay. This goes home to your mom. Did you make sure it's home?
So we need another packet.
Yep. All right, so you got this one figured out. So far we got 100 pi over 180, which reduces to 5 pi over 9. That looks familiar, like maybe I've done it before, I don't know. Is that okay with everybody? Okay, we can't be missing that kind of stuff, so everybody's clear on that. All right, now we got the same thing but backwards. 7 pi over 6 radians is how many degrees? Now the easiest thing to do here, we've been doing a lot of this in the last couple days, is to say, well, I know pi is 180. A sixth of that would be 30, and 7 of those would be 210. So that's the same as 210 degrees. You can also, and I'm not going to do this anymore, but I'll do it one more time. You can also set up exactly the same proportion, if you want to. Cross multiply, and then reduce. So 6 goes into 180, 30 times 7. So we have 210 pi over here, and x equals 210. So you can do exactly the same strategy for both of those two problems if that's what you want. All right, number 3. We're going to find the exact value, that means no calculator, of the tangent of 3 pi over 4. Okay, so, all right, so here you go, got this problem. All right, what do we do first? Probably get that degree measure. Now, understand the problem's doable in radians, but it just isn't comfortable for us yet. So we'll change that. Pi is 180, divided by 4 is 45, times 3 is 135. So we're finding the tangent of 135. Well, I just automatically gave away the next step. The next step is we want to draw a picture of it, right? That's just automatic. We need a picture. So in standard position, which means we start here, 135 would look like this. Wouldn't everybody agree with that?
Yeah.
Yeah. So what do? Draw a perpendicular, need a triangle. The study of trigonometry, triangle measurement, we need triangles. Now we got to find the important angle in the problem. What's the important angle in the problem? 45. This one right here. That's called the reference angle. You need to know that angle in order to label the sides of the triangle. We got a 45, 45, 90. So the sides are 1, 1, root 2. And then we stand back. And if we're not in quadrant 1, something's negative. We're not in quadrant 1. So something's negative. What's negative? The one on the x side, right? That one right there is negative. Remember, this is the x-axis. That's the y-axis. So x is negative, y is positive. All right, now we want tangent. Tangent, 2 definitions. You can do opposite over adjacent. You have a right triangle, so SOHCAHTOA works. So we can do opposite over adjacent. We could also do y over x. Remember, you need to know both definitions. You can't get by with Well, actually, he could get by with this one right here, just that one. But the problem is you already know Secant, so you worry about that one. But to get them both learned, either way you do it, y over x is going to be 1 over negative 1, which is negative 1. So the tangent of 3 pi over 4 is negative 1. Anybody have a question about that one? Right, number 4. Oh my. Given that the cosine of b is negative 3/5 and b is in quadrant 2. All right, now let's think about that for a minute. So b is an angle in quadrant 2. So remember when I told you that every triangle you draw is going to be part of the butterfly bow tie? Draw the part that's in quadrant 2. Won't it look like this? And I'm drawing it in quadrant 2 because that's what the problem says. Right? Now, it says the cosine is negative 3/5. Alright? So somehow I have to put that in my picture. So how am I going to do that? The cosine is negative 3/5. What do we know about cosine? Yeah, Chloe?
Cosine is the negative 3 is the adjacent.
Yeah. So I'm going to put negative 3 right here, and I'm going to put 5 right here. Doesn't that make sense to you guys? That's cosine. That's adjacent over hypotenuse, or x over r. Now what might I do? I might do the Pythagorean theorem now and fill in this third side of the triangle, because I'm going to need that side in order to answer some of these questions. Because I want the sine and the tangent and the cosecant and the cotangent and the secant. Alright, so Pythagorean theorem, here we go. 9 plus y squared equals 25, so y squared equals 16. This is 4. Many of you probably already knew that, because 3, 4, 5 is what we call a Pythagorean triple. Positive 4 or negative 4? Positive. Yep, positive 4. All right, now we can fill in the blanks. Here we go. Sine y over r, opposite over hypotenuse. The sine is 4/5. Would you agree with that? Which automatically means the cosecant is 5/4. Do your reciprocals together. Speaking of that, what was the given? Cosine negative 3/5, which automatically means secant must be negative 5/3. Because secant is reciprocal of cosine. Alright, what's my tangent? Opposite over adjacent, negative 4/3. Which means your cotangent is negative 3/4. Easy peasy, got it? Now, number 5, I can't remember. In some class yesterday, I talked about this word, and I don't remember if it was yours or not. Have you seen the word coterminal before? No. Well, it's a good thing we're going to see it today. Coterminal. So let's find one angle coterminal with 60 degrees. First of all, there are infinitely many answers. So I'm just going to list some of them, and you tell me what's going on. What do we mean by coterminal angle? So the given angle is 60. So some angles coterminal with that would be negative 300, positive 420, 780. These would all be examples of coterminal angles. And there are zillions more. Literally zillions more. What do you think it means to be coterminal then? Think about all those angles. maybe draw them. Like here's 60, right? What would negative 300 look like? Same thing. Actually, it ends in the same spot, right? When I draw it, I end in the same spot. Wouldn't this be negative 300, you guys? The word coterminal means it shares a terminal side or an ending side. Remember, all of your angles start here. That's the initial side always. This is called the terminal side. That's where it ends. Well, both of these angles start and stop at the same place. So coterminal means they share the same terminal side. Or, as somebody up here said, they end in the same spot. Now, is that true of 420? What does 420 look like when you graph it or draw it? It goes all the way around, and then 60 more. So doesn't it end up in the same spot? What about 780? Goes around twice, and then ends up in the same spot. Coterminal angles. So, I did that problem for you. Your job was to, name one of those, and I named 3 of them. How did I get these numbers? What did I do in my head? What math was I doing? What? I added 360, and I subtracted 360. And I could keep doing that. If you want to find coterminal angles, you simply add or subtract revolutions. So and if I'm in degrees, I'm going to add and subtract 360s. So if I said to you, take 100 degrees, find a coterminal angle for 100 degrees. Well, what would be one coterminal angle for 100 degrees? 460. You find coterminal angles by adding or subtracting revolutions. So these would be the first two, right? Add 360, subtract 360 from 100. And then if you needed more for some reason, you could add 360 and subtract 360 and keep going as many times as you needed to do. Now, notice when I told you how to find coterminal angles, I said we add and subtract revolutions. And the reason I want you to think about it that way is, what if the original angle were 2 pi over 3 radians? Now certainly we wouldn't add 360 to that, right? What would we add to that? A revolution. What's a revolution in 2 pi? 2 pi. 2 pi. Revolutions are 2 pi's. So we would add or subtract 2 pi, which is 6/3. I need a common denominator. So a positive coterminal angle would be 8 pi over 3. And a negative coterminal angle would be negative 4 pi over 3. We add and subtract revolutions. If we are in degrees, that's 360. If we're in radians, that's 2 pi. Okay? Alright, we got that. Let's turn it over. I think there's a back side. Oh no, there is, but it's a different quiz. But that's okay, let's do this quiz. Because it's got some good calculator stuff at the bottom. Alright, so here we go. Given angle X as shown. There's some just like this in your homework, so you'll be, if you've already worked on them, you know that. If not, this is how you do it. So this is the given. And we're going to find sine, tangent, and secant. Alright, so here you go. What do we do? we need a triangle. Let me say it again. This is trigonometry. Trigonometry means triangle measurement. You got to have a triangle. All right, so here we go. Tell me about that triangle. Do I know anything about its sides? What's this
Two
side?
sides are negative.
What's this side? How long?
1.
-2. What's this one? -3. Kids, if this is the point, -2, -3, and this is the origin, don't we have to go left 2 and down 3 to get to that point? Shake the cobwebs out. That's not tricky. We gotta go left 2 and down 3. Okay, now, I'm missing this. Can I figure that out? Pythagorean theorem, so a squared, b squared, that would be the square root of 13. That number, by the way, will never be negative, right? Everybody remembers that, made a big deal about it the other day. That number is always positive. Do I have enough to answer the question now? I surely do. What's the sign? Here, this is always the key angle right here, kids. So it would be -3 over root 13. Or -3 root 13 over 13. What's my tangent?
3/2.
Positive 3/2. The negatives cancel, right? Secant. Secant is reciprocal. Patty, are you paying attention to me?
Yes.
Patty? Secant is reciprocal of cosine. Cosine is adjacent over hypotenuse. So hypotenuse over adjacent. Is that what I need? So root 13 over -2. Get a fraction like that, by the way, does it matter where I put the negative? No. So don't get all hung up about that. If you want to put root 13 over -2, that's fine. Where you put the negative isn't important. All right, anybody have a question about that one? All right, now we've got a few of these, so you should probably be okay with these. We want to find the cosine of 60. Anybody want to volunteer to come up and put that on the board? This is just like praying at department meetings. I lead over my department. Would anyone like to lead us in prayer this morning? And everyone just sits there and looks at me. And, okay, I'll pray. So, okay, I'll do the problem. Here we go. Cosine 60. What do? No, I don't want to put it in radians. I mean, well, wait a minute. Could I put it in radians? Yeah, but I probably don't want to do that.
It'd be redundant.
I'm just going to draw a picture
Just
of it.
plot it out.
Yeah, I'm just going to plot it out. Yeah, I'm just going to draw my 60-degree angle and drop a perpendicular down to the x-axis, right?
Alright.
Now, can I label the sides of my triangle?
Yes.
Across from the 60 is?
It's 2.
Across from the 60 is?
Oh yeah, this is a
Root
Pythagorean
3.
Birthday present.
Across from the 30 is 1, and my hypotenuse is
Yeah.
2.
And across from the 60 is.
I don't know how else to say it, but you got to have that memorized.
I was saying it, but.
But I wasn't listening. That happens sometimes. All right, what's the cosine? Cosine is adjacent over hypotenuse, so the answer is 1/2. Now we've got one of the tricky ones we talked about yesterday, the tangent of 90. What makes this tricky? It is a quadrantal angle, right? It's right here. And when it's a quadrantal angle, I can't draw my triangle So I rely on my other definitions. Tangent is y over x. So I need to figure out the x and the y right here. At that point, at 90 degrees, I need the x and the y. Well, what will the x and the y be? 0, 1, if I let the radius be 1. And the answer is undefined. 1 over 0, undefined. That's why when you look at your tangent picture, at pi over 2, there is an asymptote. It's undefined at 90 degrees. And then the cosecant of 5 pi over 3. Turn it into degrees, probably. Okay, I don't want you to think you have to do that, but it makes it easier for us, I think, at this point. So in degrees, that would be, well, that's 180, that's 60, times 5 is 300. So I'm finding the cosecant of 300. So I'm going to draw 300 in standard position, and it's going to look like this. Would you agree with me?
Yes.
Alright, then what am I going to do?
Your bow tie.
Make my bow tie piece. Yep, right there. Take that perpendicular straight up, and then find the measure of that angle right there, which is critical. The measure of that angle is 60. Right? Across from the 60 is root 3. 1, 2. Stop. I'm not in quadrant 1, so something's negative. The root 3 is negative. Everybody get it? Root 3 negative. Now I want the cosecant, which is the reciprocal of the sine, which is opposite over hypotenuse. So this will be hypotenuse over opposite, or r over y, depending on what definition you're using. So what will that be in this picture?
2 over square root of -3.
Yep, 2 over negative root 3, which is going to be negative 2 root 3 over 3. Got it? Alright, get your calculators out. Now we're going to do a little work with our calculators. Now, some of this we've already talked about, a couple of these we have not. Do we know how to put 12 degrees 10 minutes into our calculator? Yeah, we know how to do that. Now what we have to do is figure out how to take the secant of that. You paid $100 for this calculator, or more than $100 for this calculator, and it does not even have a secant button, right? There's no secant button on this calculator. I'm going to say that again. There is no secant button on this calculator. I don't want anybody thinking that's a secant. It is not. We're going to talk about what that is, but it is something not secant. If you want to type a secant in on your calculator, which we apparently do, you must remember the definition. The secant is the reciprocal of the cosine. So I type literally 1 divided by cosine 12 degrees 10 minutes. So 1 divided by 12 degrees, cosine 12 degrees, 1 divided by cosine 12 degrees. Everybody remember how to find the degree mark? And the minute mark. They're in the same spot. Thank goodness. And what did you come up with as an answer? 1.085. What? Okay, here's what I need you to do. Go to mode. make sure you're in degrees. Go to mode, there's a mode button. Press the mode button. Is degrees highlighted?
No, it's not. It's fine.
So we need to make sure we're in degree mode. So, then I want you to go back and I want you to type this in again. And I want you to come up with 1.022977431. That's what I need you to come up with.
When I changed it, I got the same answer.
When you what?
When I changed it from radians.
And normally that is okay, because as soon as you put the degree symbol in, it's supposed to interpret it as degrees. But since she wasn't getting that, I didn't know if there was something going on with that calculator or whatever.
I got a different answer.
Oh, you need it to be in degree mode.
Yeah.
So if it's in degree mode, this will be the answer to the question. So you need to type exactly what I wrote, and you should get that answer.
Are you supposed to type in parentheses?
When you hit cosine, parentheses automatically come up, and then 12 degrees, 10 minutes. All right, let's try the next one. Tangent 5 pi over 7. Oh, stop. 5 pi over 7. That's not degrees, is it? So if I want to type that in, I got to go to mode and change my calculator into radian mode. So make sure radian is highlighted now, because this is a radian measure. You want it to find the tangent of 5 pi over 7 in radians. So change to radian mode and then type tangent 5 pi, use your pi button, divided by 7. And you should get negative 1.25396 as your answer. So make sure that's what you're getting. Make sure you have gone to mode and changed into radian, because this is a radian measure. And then type tangent 5 pi, pi button, divided by 7. Everybody getting that number?
So why didn't we put a 1?
It's tangent. Yep, and tangent I have a button for. Now, I really don't want to be switching back and forth, so I'm going to do all the radians. Since I'm in radians now, I'm going to go through and do all the radian problems. C is actually a radian problem. How do I know that? How do I know that means sine 2 radians? Well, I didn't tell you this before, but I did tell you that your time with degrees is limited. I mean, we're phasing out degrees. Radians are so common that if there's no unit shown, if it just says sine 2 or tangent 5 pi over 7, that's a radian measure. If they want you to do degrees, they will say degrees. So it would say sine 2 degrees if it meant for you to do it in degrees. If there's no degree mark, then it's a radian measure. Okay? So that one's easy. We're just going to press sine 2. That's what it is, right? Yep, sine 2. Make sure you're in radian mode, and you should get 0.909. Other stuff, right? Everybody getting that? That's easy. Now E is also a radian. Would you agree with that? But it's a cosecant. Okay, now wait, I do not have a cosecant button. What do I know about cosecant? It's reciprocal, that means 1 over, so it's 1 over sine 11 pi over 13. Okay, so I'm going to literally press on my calculator, 1 divided by sine, and then 11 pi button divided by 13. And this is in parentheses, of course. and you should get 2.1518. If you don't, type it in again, type exactly what you see up here. 1 divided by sine 11 pi button divided by 13. Don't put in any extra parentheses. You don't need any extra parentheses, just the ones that are around the angle that pop up automatically. Everybody getting 2.1518? All right, and the only thing left there is D. D is a degree measure, so let's go back to mode. Let's change our calculator into degrees. And then we're going to type in cosine. We have a cosine button, so we just type cosine. 183 degrees, 12 minutes, and then 11 seconds. And remember where that seconds thing is? It's over on your plus sign, remember? So alpha plus. And did you get negative 0.9984? Everybody okay with that? The next page of the packet is to be done as homework, those 10 problems. So I want you to go to the next page, that would be page 3. Actually, no, I don't. I want you to go to page 4. Sorry, page 4. All right, here we are on page 4. This is a review sheet kind of type thing. So here we go. We're getting ready. We're going to do it. Number 1. Deep breath. Sine 5 pi over 3. Kind of already did that, didn't we? Oh well, let's do it again. I'll erase it. Pretend we didn't just do it. 5 pi over 3. We want this time we want the sine. So we're going to change that into degrees. So pi is 180. Divided by 3 is 60 times 5 is 300. So we're finding the sine of 300. So we just did this. This is 300. How big is my reference angle? 60. Which means this side over here is root 3. And then since I'm not in quadrant 1, I know something will be negative.
The root 3.
The root 3 is negative. Patty, I need you paying attention. Are you on your packet, page 4? This would be superb if you were. Now, I want the sine. What's the value of the sine? Opposite over hypotenuse, negative root 3 over 2. I feel like you should be able to do those in your sleep. All right, number 2. Oh, there's that picture again. What pops into your head when you see that picture? Arc length. And arc length is radius times radians. So I know to do these problems, I'm probably going to be using this idea. So here's what's given. In problem A, we are given a central angle of 4 pi over 9 and a radius of 8, and we're asked for the arc length. Here we go. Arc length, radius, times radians. Answer 32 pi over 9. If there were a unit, it would match this. So if this were 8 feet, That would be 32 pi over 9 feet. Alrighty. Can you say easy? Yeah. B. B is the same situation, except this time we know the radius is 10, the arc length is 18, and you want to know the angle. Arc length equals radius times radians. I'll put theta. So what does theta equal? 9/5. And what's the unit on that 9/5? Radians, that's right. You don't have to write that in, I will, just to remind us. That's 9/5 radians. Now, notice there's no pi in that 9/5. That's perfectly okay. Radian measures often have pi's in them because after all, a revolution is 2 pi, but they don't have to have them. 9/5 is the answer. Sometimes I'll give a quiz and a kid will get 9/5 and then stick a pi in there just randomly. No, it's 9/5, 10 over 8, or 18 over 10. All right, number 3, do we know how to do problem 3? .5 radians is how many degrees? What's our strategy? Do not make me stressed. You know this. Pi is to 180 as 1.5 is to x. That proportion is true all of the time. Pi radians are 180 degrees, so 1.5 radians are how many degrees? That's the question. So pi x equals, what's 1.5 times 180? 270? So 270 over pi degrees. Find a positive and a negative coterminal angle for 230. Okay, we just talked about that this morning. How do we find coterminal angles? Add and subtract revolutions. Now this is a degree measure, so we will add and subtract 360. So a positive coterminal angle would be 590. And then a negative coterminal angle would be negative 130. Right? Since that's brand new, we got a little bit of space there. Let's do that. Let's find a positive and a negative coterminal angle for pi over 4. So we're going to do exactly the same thing. We're going to take our pi over 4, but we're not going to add and subtract 360. What are we going to add and subtract? 2 pi. That's a fraction. So instead of thinking of 2 pi, I'll think of 8/4. So I'm going to add 8 pi over 4 and subtract 8 pi over 4. So my answers are 9 pi over 4 and negative 7 pi over 4. That would be my positive and negative coterminal angle for pi over 4. Okay, number 5, find the tangent of pi, which is finding the tangent of 180. Would you agree with that? So here we go. Some of you are writing. I hope you're writing math. What are you writing?
Math.
Well, I know. What are you doing? What are you putting down on your paper right now? You drawing a picture? Or visualizing? Where's 180? right here. It's on an axis. So I can't use opposite over hypotenuse. I'm gonna have to, or opposite over adjacent. I mean, I'm gonna have to use y over x. So I need this point. What would the coordinates of that point be? -1, 0, if we use a radius of 1. So y over x, 0 over -1, which is 0. So the tangent of 180 is 0. Oh my goodness. Oh my goodness. 6 and 8 are kind of the new ones on this sheet. 6, oh goodness. Oh goodness. What if I told you to do this without a calculator? Wouldn't that be awful? Let's talk about that for a second. Normally, I avoid mixed numbers like the plague. By mixed numbers, I mean things like 5 and 2/3. Normally, we avoid those. But what I'd like you to do is change 183 fourths into a mixed number, because I want you to notice something. So let's see, if I do my division, right, keep an eye on this, I'm not always the best at division. Is it 45 and 3/4?
Yeah.
Alright, so what I'm really asking in this problem is find the cosine of 45 and 3/4 pi. Now, why is that helpful to think about that? Well, this is what I'd like you to do. I'd like you to think of that 45 as 44 pi and then 1 3/4 pi. Now, just hang in there for a minute. Tell me about 44 pi. Well, forget the 180 and times all that. Think about just what does 44 pi look like if you draw it? It's 22 revolutions. And when I'm drawing 22 revolutions, do those even really matter?
No.
The only part of this problem that matters is the 1 3/4 or the 7 pi over 4, 1 3/4. That part matters. All of this extra stuff, if you're saying 45 pies, 44 of those pies are meaningless. They're just spins. So I'm going to ignore those. If I don't have a calculator, I'm going to ignore those 44. This is manageable.
Why do you care about the 1 revolution by the 3/4?
Okay, 1 pi is not a revolution.
Oh, okay.
Remember, 2 pi is a revolution. So I can't, 45 pi doesn't end me up back where I started. It ends me up over here. Right? And I don't want to deal with that. I want to end up right back where I started. So those are 2 pi's. Okay? So I get rid of all the 2 pi's. Now, even if you had a calculator, when you change this into degrees, you're going to get a huge number, right? And what are you going to have to do with that number? Start getting rid of 360s? I'm just doing it right now. I'm getting rid of 22 revolutions right now. So now I can do this problem. Pi divided by 4 is 45. That's 315. So 315, there it is. Reference angle is 45. Anything negative?
-1.
What, this one, right? That one is negative. I want the cosine. 1 over root 2, or root 2 over 2. This angle is humongous. If you change it into degrees, which is fine, You still gotta get rid of those 360s. Get rid of them. I left it in radians because maybe I won't have a calculator. So I left it in radians and got rid of not 360s, but got rid of 2 pi's. Even pi's can go because they're revolutions. Got it? Oh, you're all just wishing I'd just shut up. Number 7, find the values of the 6 trig functions. Oh, what's going on here? All right, let's see if we can figure this out. I think we already know how to do this. We want to find the values of the 6 trig functions if the tangent is -3/4 and the sine is negative. So I want sine, cosine, tangent, cosecant, secant, and cotangent. It says find the values of the 6 trig functions. Now they tell me already the tangent is -3/4, which means the cotangent's -4/3. So without doing anything, I get 1/3 of the problem right. 2/6 are done from the given. Now, here's the dilemma. You understand you're going to draw a triangle, right? And you're going to draw a triangle where opposite and adjacent are 3 and 4, and one of them's negative. That's the problem. Do I know which one's negative? No. So I could draw a triangle where this is 3 and this is -4. Would that have a tangent of -3/4? But I could also draw a triangle where this was -3 and this was 4. Would that have a tangent of -3/4? Yes. So when this is what they give me, it could happen in quadrant 2 or in quadrant 4. So then they gave me this additional piece of information. They said, whatever the sign is, it has to be negative. Which of these would have a negative SINE, a negative sign value? Which quadrant there would have a negative sign? Well, is the opposite side negative here? Is the opposite side negative? No. Is the opposite side negative here? Yeah. So this is the quadrant I want. This is the one I want. So I'm drawing my picture in quadrant 4. I had to figure that out, kids. You had to think about that. Now what's that third side going to be? Pythagorean theorem. Pi. So the sine is -3/5. Cosecant -5/3. Cosine 4/5. Secant 5/4. Yeah.
It just says that the sine of x has to be less than 0.
That means negative.
Yeah, I know, but if you did them, it'd be -1 up there and -3/4.
Wait a second. You talking about up here in this quadrant?
Yeah. Sine, oh, it's not sine,
Yeah. No, it can't be here because the sign is positive in quadrant 2. Remember, as you start thinking about these positives and negatives, and they're huge. You gotta pay attention, really close attention, but as you think about them, remember your definitions. Sine is y over r. Sine is going to be positive whenever y is positive, and it's going to be negative whenever y is negative. Same thing with cosine, only you don't look at y, you look at x for cosine. So if you want cosine to be positive, it's over here, where x is positive. All right, one more. figure out what we're gonna do next. How about I just sit down and shut up, Mrs. Ford? Maybe, let's see. Draw your triangle. It's a right triangle. We are given that's 5, that's A, this is 62. Let's see, all right, we might as well talk about this right now. First of all, when we say solve a triangle, what that means is find every missing piece. Triangles have 6 pieces, 3 angles, 3 sides. You will always be given 3 of those pieces. Think back to geometry, angle, side, angle. Angle, angle, side. Side, side, side. You're always given 3 pieces. Okay? Always. And usually when I say that, some hand goes up and says, what about hypotenuse leg? That's only 2 pieces. No. Hypotenuse leg is 3 pieces, because if you got hypotenuse, you know you have a right angle and the hypotenuse and a leg. You always have 3 pieces given. And then, in this case, in solve cases, your job is to find the other 3. When you label a triangle, we use capital letters for the angles. And then small letters for the sides. If this is angle A, this will be side A. They're labeled opposite their angle. So here's angle B, so this is side B. Here's angle C, this is side C. Now that's just the way it's done, so that you're going to have to conform to that rule. Capital letters for the vertices, for the angles, small letters for the sides, and then sides are, so if we had D, E, F, this would be side E, this is F, and this is D. Got it? Okay. Now, we need to figure out stuff here. So what do we need to find? We need to find angle A, that's missing. We need to find side A and side B. Those are the missing pieces. Can you find any of those right now? Angle A. What do we know about the angles of a triangle? They add up to 180. So angle A must be 28 degrees. Would you agree with that? All right, let's suppose we want to find side A next. It doesn't matter. The order doesn't matter. But let's just pick one. We'll do side A next. Any idea how we might find side A? Oh, the tangent of 28 equals A over 5. Now, let's talk about why she picked tangent. If we had decided we were finding angle A, do you see why she picked tangent?
Yes.
Because she had this side, right? Which is the adjacent side for 28. That's the adjacent side. And this is the opposite side. So she said, I'm going to use tangent. Very good. So A is 5 tan 28. Before you type this in, take a split second and check your mode. What do we need to be in? If we're typing this problem into our calculator, we need to be in degrees. You will, oh my gosh, it's been several years ago, but some kid took an entire test in a law cosines and sines in the wrong mode. Oh my gosh. So everything will be wrong. You have to do it in the right mode. So we're in degrees.
Oh, geez.
So 5 tan 28. Side A is about 2.66 if I round off to the nearest hundred. Do you agree with that? All right, now I want to talk about side B. Is anybody thinking Pythagorean theorem? Okay, let's talk about that for a minute. You can do the Pythagorean theorem as long as you use the number on your calculator, your answer button in other words, and not 2.66. Because if you literally use the 2.66, you're introducing round-off error into the problem, right? And it's not necessary, because there are other ways to do the problem. So if you want to do the Pythagorean theorem, that's okay, but use your answer button on your calculator. Personally, I mean, and that's fine. That's absolutely fine. Personally, I don't know, if I'm finding side B over here, I might say cosine 28 equals 5 over B. Would that be true? And then I don't have any round off there either. It's okay. And so B cosine 28 equals 5 and B equals 5 over cosine 28. So I'm going to do that. Those of you that did the Pythagorean theorem, we're going to match exactly because you didn't do any rounding off. 5.66285023 is what you should have no matter how you did the problem. So, pay attention to me when I say I'm a stickler about this round off stuff. Obviously, when you write an answer down, you have to round it off. We can't write all that out for every problem. We're not going to. However, if you choose to use this answer later on, use the stored version of it in your calculator, not the version you wrote down. Got it? Alright. Well, that's good. We should be able to do now all of the homework up through and including 4-3. Alright. So all the homework up and including 4.3 should be done. That means you know everything